Hello guys, welcome to today's GFG POTD. Here we are given a question of brackets in chain multiplication. Okay, so we are given an array of P. We are given a length 5 and this is our array of P. Here each number denotes the size of the matrix. Suppose if I traverse from 1 to 2, it suggests that first matrix is of set 1 cross 2. Then 2 cross 3 means second matrix is of order 2 cross 3. Then third matrix is around the 3 cross 4 and fourth matrix is of 4 cross 5. So we will have n minus 1 matrix for n given for a given n. So we have to find out the minimum possible multiplication operation to multiply all these five matrices with providing parentheses. Because as we know in matrix multiplication, the order of the matrix depends multiplication operation depends upon the order of the matrix multiplication. So let's go to our test case. So here we are given an array 0 with this is the index and this is array. Okay, so we have made four matrices. This is 1 cross 2, 2 cross 3, 3 cross 4 and 4 cross 5. So when we multiply A cross A into B, we get a matrix size of 1 cross 3. And number of operations required to do will be for each element, we have to multiply each with each row by column. So 1 into 1 and 2 plus 2 into 2. So for each, we have to perform two multiplication operations. So the total number of multiplication to get AB is 6. Then for BC, we have to multiply these 3. So 2, 3 and 4. So total operation required to multiply BC will be 3 into 4 into 2, that is 24. And then CD, to multiply CD, we need total of 3 into 4 into 5 operations, that is 60. And then we will continue the process and find out which possible parenthesis give us the minimum order. So this is a question of DP. We will make a DP function and we will traverse. Suppose this is my ABCD required matrix, so we will apply bottom to top approach. So here I have this ABCD. It can be performed in three possible ways. If I apply a parenthesis here, if I apply parenthesis here, and if I apply a parenthesis here, A, B, C, D. Okay. And this further can be divided into two parts where I take BC common, then multiply it with A, and then if I take AB common and then multiply it by C. And in this branch also we will get two possibilities. We take CD common and multiply it by B, and we take BC common and multiply it by D. Okay, so in each of the cases we will have different types of different number of operations. So we will return the minimum operation from this branch, minimum operation from this branch, and minimum operation from this branch to get my minimum number of application. For this we will use DP. Okay, so how we will use DP? Let's go back to our indexing thing. Suppose this is 0 to 4. Then I have split it into three parts: 0, 1, 1, 4, 0, 3, 3, 4, and 0, 2, 2, 4. All right, so we will make this DP. How we will make this? Let's get back here. So for getting BC, we need to have this many number of operations: 2, 4, 2, 4, and 3. That is 12 operations. 12. Then 12, and then we have to multiply it with by A. Then will have to perform 32 operations. Then for A, B, C, D, it will take 20 operations. So the minimum of this is, sorry, 18. 6 plus 12 is 18. 18 operations. So I will fill 18 in my part. 18. And here how I am making the DP table. For this whole will be 0 and multiplication of A with itself is 0. To if you do not apply any operation to get matrix A, then it will be 0, this will be 0, this will be 0, and this will be 0. So my this left part is whole 0. In our programming we will use -1 because it will be much easier for us to identify. And then for 2, for splitting the array into two parts, like from 0 to 2, 0 to 2, we can have we will have AB. We have to make AB 0 to 2. 0 to 2 means this portion, and to get this portion we have to have six multiplication operations. Then to get BC we need to have 24 as already discussed, and to get CD we have to apply 60 operations. So we have filled 60. Okay. C 2 comma 4. 2 comma 4 is 2 comma 4. Then from 3, 3, 0 to 3. 0 to 3 means ABC. For ABC, we need to have 32 operations. Sorry, 28 operations, we will return the minimum. 18 operations, we have returned the minimum. And similarly, from this branch, we will return 64. and then we will take the minimum of this, we will get 38. And then also I have to make a bracket table, because we have to print out the string. So where we are putting the parentheses, these numbers indicate where my closing and opening parentheses are. So let's get into the coding part, and I will explain you the code as I write it. Okay. So here is my interface. Okay, so this is my test case, and here I've created a solution class. I have made a string, global empty string, where the changes will be made in the string, and a character name A, as we have to print in the order of A, B, C, D, and so on. Okay, so I've made the order. Now I've created, this is the function, our main function, and we are initializing str name and making a table dp and bracket. I have made two tables, one for bracket and one for DP, as we have already discussed. And then in the DP, I filled all the uh, rows and columns with -1. Okay, this is just for visualizing. This is nothing to do with. Then we have called the function solve. I have called the function print optimal parenthesis, and then I have returned the str. Okay, so this is my print optimal parenthesis function, and this is first we will have to create the DP table and the bracket table. Okay, so let's uh, start this function. If I is greater than equal to j, I will return 0. Okay, means it's done. Okay, then if dp of I and j is not equal to 1, not equal to -1, means it is changed, then I will return dp of I j. Okay, and then I will create a minimum integer dot max value, which will give me the minimum path, and then int k is equal to sorry, for int k is equal to 0 to k less than j, k plus plus. I've created a temp function where I will recursively call solve, and the solve will be as follows. I will pass my array p, I will pass my index I will pass the k, I will pass my dp, I will pass my bracket. I will pass these four things in my temp. Okay, and I will add what? I will add the solve p comma k plus 1, my next index, comma dp, comma bracket. Wait, I missed something. P comma j also. I have to pass j also. Okay, I am incrementing k here, and also we have to perform p of I minus 1 star p of k star p of j. Okay, now here, after doing this, if my minimum is less than temp, then I will update my temp and fill my dp. Okay, then my minimum is equal to mat dot min of minimum comma temp. Okay, and then I will fill my dp with minimum value. Dp of ifj is equal to mean, and then I will also have to update my bracket, that where my bracket should be placed as bracket of I comma j is equal to k. Means this is my breaking point. Like if I go into ppt part, um, what is this bracket signifying? See here, uh, uh, here I am. This is my k where my splitting is done. As this is the minimum part, the k will ultimately be equal to 3 for this part. Like I'm putting the bracket here. For this part, the k will be equal to 1 because my splitting has been done, and here my splitting will be along 2. Okay, so here I have to make this complete thing under the if. So now after this, I have to put this under this complete statement under the if function, and then wait, this whole thing should be under the if function, and then after this I have to return minimum, return min. Okay, so this will completely make our dp. This one extra. Wait. return mean, and then this. Okay. Now I have to complete my void print function to print the parentheses. So as we are passing a bracket which is signifying where our bracket should be placed. So this is also recursive function, uh, print the parenthesis. Suppose if my I is equal to j, means we have to increment ab, like for three matrices there should be a b c, so this will continuously increment. So str is equal to str plus name, and then name plus plus name plus plus. Okay, and this should be under one if. So this will create name. Then after this, if this is not the case, if my I is not equal to j, then I have to use str plus is equal to opening bracket. I have to open my bracket. So my opening bracket, and before that I have to also get my bracket value, bracket of I j. Okay. And then after this, print optimal parenthesis. We will pass I k and then bracket matrix, and also we will do the same, but here now we have to place a closing bracket, so k plus 1 j and bracket, then str is equal str plus is equal to closing bracket. Okay, so this will completely solve the part, and also here it should start from I. Okay, so this is a complete function. Let's test it. So initially this is my DP array and it is all filled with -1, and this is my bracket array before calculation. This is also filled with 0. Now after calculation my DP is updated to this function with 6, 24 and 60. This is AB, BC and CD, and this is the minimum case when we split it ABC, and this is the minimum case when we split it BCD. And after this, when we combined all the three, this is the case. You can also see in the PPT, this was exactly our table. See, this was exactly our table: 6, 18, 34, 64, 60 and 38. Okay, and then uh, and my bracket is being altered as 1, 2, 3, 2, 3 and 3. 1, 2, 3 signifies see, 1, 2, 3 signifies my opening brackets, and this is my closing brackets, and ultimately my final close was on 3. I've opened all my brackets, and the first bracket is closed after second position, and third bracket is closed after second bracket is first bracket is closed after second position, then after second position, and then third position. Okay, and ultimately my string is being printed. So let's paste the code in GFG and then submit our code. Hopefully it passes all my test cases. This is it. I have to change my solution name, and I have to remove what I was printing. This was all printed. Then this was also all printed, and I guess we are good to go. Also, I have to remove one more bracket. This this part. See, this is my output and expected output. Let's submit our code. Okay, guys. So this is our code for today. Hopefully you got the concept. Today it was a hard question, and the complexity was also undue. And it would be much more easier if we just had to return the maximum multiplication operation, but as we have to give the output as a string, suppose we just have to return this number 30, then we could have easily done it by printing, like if I print as out, we don't system dot out dot println dp of 0 comma and -1. So we don't need this function at all. We don't need this bracket function also. If I just simply compile it, you can see my output will be 38, which will be displayed. Wait for a second. It is not 0, it should be 1. See, this is the answer. We don't need this function, but as we have to do we have to return the string. it becomes a good problem. So hopefully you enjoyed today's video. We'll meet in next video. Thank you.